Hi everyone, we're going to walk through model training and testing and scoring Kaggle leaderboard for our Deep Neural Networks or DNN course. My name is Oleg Melnikov. Let's learn. We have a diagram here that I will walk through, starting with 200,000 diamonds or rows in a table in a diamonds competition dataset. Let's look at data tab on Kaggle.com for this competition. We have description of each attribute and last variable is a target. You can read more about this in the source of this data, although the dataset has been modified, so you can't directly apply external models to it, but you can certainly learn a lot from the dataset and the models that people post on the internet. The files that you download automatically with Kaggle API is xy_diamonds.csv. That is a tabular format data where each column is an attribute until the last 10th column, which is a price. You have this distributions here. We can look at compact or a column view with distributions and number of observations. If we scroll down to the last variable, price, it has 160,000 valid prices and 40,000 missing prices that you must predict. 160,000 can be split up many different ways for your training if you want validation and testing locally. Once you build your best model, you can pass 40,000 observations that do not have prices, make predictions, and send those predictions to the leaderboard by loading your CSV file through the Submit Predictions button. If you click Submit Predictions, it'll ask you to select a file, and you can do this programmatically with Kaggle API. Once you click Submit, you will receive a score in this leaderboard. If your score is higher than the score of the team above you, you will be moved up by one rank. This score will move you up on a public leaderboard, but may not necessarily cross the rank of the team above you. Your goal is not to just improve your score, but also to climb up in ranks. The final grading of this leaderboard component will take into account your position in the private leaderboard. I'll explain that shortly. If we go back to this diagram, we start with 200K of rows or diamond observations. 160 of them will be priced or labeled. You can use those for training or unlimited scoring in your local environment, being personal computer or AWS or Colab, any one of those which is not Kaggle.com. And you can do Kaggle.com pricing and scoring 40,000 unpriced rows that you build predictions for. This can only be done twice a day. If you only build 2 models per day, it's sufficient to build a model, train it, make predictions, send them to Kaggle, and see if that helped you move up in ranks. If you are climbing up in ranks, but your teammates are not, once you merge your team in Kaggle leaderboard, the best rank will be assumed by all other teammates in your team. We grade the whole team with the same grade adjusted for participation as evaluated by teammates. You're not limited to twice a day scoring locally. You can do unlimited number of scorings. This is somewhat more complete way of doing experiments locally. You can split 160K into approximately equal sized chunks and train one model on, let's say, 60K. The model will optimize its parameters to minimize the error between predicted and observed prices, because the prices are known here in any one of these orange blocks. Then the absolute differences in prices will aggregate to mean absolute error. And that's what Kaggle uses to compute your score and rank on the leaderboard. You don't have to use MAE locally. You can use MSE or RMSE or any other metric, as long as you think that improvements in that metric are indicative of your improvements on the leaderboard. I would start simple with just MAE, unless you have a strong reason not to use it. I would start by using the starter Colab with the baseline model, and then slowly and gradually making experiments more complex so that you can better predict the leaderboard scores that you will receive. The validation allows you to train many models, thousands. They can be from different model families, such as linear regression or piecewise linear regression or regularized regression, with different hyperparameters or different sets of features. So linear regression with 2 features will have 2 or 3 parameters, depending on whether you use intercept term or not. If you take powers of those attributes, you will have approximately twice as many parameters. You will have original parameters plus the powers. You can also use the interactions, let's say x1 multiplied by x2, or more interactions can be accounted for. So you quickly create a larger number of variables in your linear regression, and each one of those variables will require a slope coefficient from your model during training. You can do all those experiments in validation, and using 50,000 labeled observations, this step will pick the best model, where each model will be trained on a 60K. That best model performance is overfitted to the 50K here. So you want to run it one more time to test the best model M's performance, so that you would relate that score to what Kaggle would compute. We're assuming here that the distributions of 160K and 40K are the same, but it may not be. You have to be on the lookout for outliers. The outliers are observations that have unusual to the considered distribution values. And if you see those outliers in the training, you might want to remove them or trim them somehow or treat them so they minimize the effect on your model. You can also consider models that are less sensitive to outliers and minimize the outliers effect in the attributes of your test set with some post-processing, as we will see in the Colab. If you notice that the predicted price is negative or extremely large, you might want to trim it, but you must keep it. You can't throw it away because Kaggle will expect that price from you. You will experiment unlimited number of times locally and pick your best model. Model may execute more or less than 60 seconds, which is okay. It might run for 5 seconds or it may run for 5 minutes. Whatever you submit to us needs to run under 60 seconds. So you can take your best model and its parameters and train it one more time on a smaller subset or a larger subset. If it takes too little to train that model, you can increase the number of examples. If it executes too long, you can retrain it on a smaller subset. You will get a different model with different model parameters. The hyperparameters will be the same because you fixed them, but the model will train and optimize parameters within, such as intercept and coefficients, and you will use that final model to predict 40,000 prices. At that point, you will send the CSV file to Kaggle, not the model that you built, not the Python code, but the CSV file to Kaggle. Kaggle will split this into public and private leaderboards. You will not see your private leaderboard scores until the competition closes, but you will reference public leaderboard scores as a proxy for your private LB's performance. Here we have your team's exemplified scores. Suppose you made several different predictions from top to bottom. This is the most recent, this is the oldest, and the first one is close to baseline, and the next one is an improvement, maybe next one is not, next one is improvement, next one is not. Each one of this will be linked to some private leaderboard score. Your public leaderboard will show you that 415 MAE is your best. Out of all these different models, this score will appear with whichever rank, maybe rank 1. The private leaderboard will likely have a different score. The goal is not to have identical scores. The goal is to have the same rank. If you correctly utilize public leaderboard as a proxy for private and treat it for outliers and build a model that generalizes for the unseen observations, then the rank 1 should be maintained as such in the private leaderboard once it opens, meaning that your score is lower, but probably everybody else's scores are also lower because of an outlier in a dataset or some other tweaks that affected all the other teams as well. But it may vary. It may be that you overfitted the public leaderboard and 620 sent you from the top 1 rank to top 5 rank, and that needs to be avoided. That means you build your model for the public leaderboard, not for the private that it represents. Your best score in a private leaderboard could be from a different model on public LB. Let Kaggle pick the model that it will use for private leaderboard. Remember, smaller MAEs are better. Errors should be smaller. 1080 is the worst in this set. 415 is the best. Kaggle will recommend that you use the model that generated this for final submission. Unless you have a strong reason not to, we recommend that you accept Kaggle's default. Once the competition closes, our graders run your Colabs on the dataset of the private leaderboard. The same 20,000 observations should reproduce the same same MAE. In most cases, until we get to GPUs and TensorFlows, this should not be a problem. If you seed all your random number generators, then your 620 MAE should be reproduced. If it's not reproduced, it's not a big deal. It can vary a little bit. If it starts to vary a lot, that means there's something wrong between the collabs that you sent us and the collabs that you used to create a CSV files that you sent to Kaggle leaderboard. We want to avoid these situations. There will be penalties for either not reproducing the same score or for using the wrong model. Let's say a team used XGBoost model to improve their leaderboard score. It's a powerful model, but we haven't studied it yet. In this competition, we use linear regression. They submitted linear regression to us. We can't reproduce their score. We re-rank all teams according to the scores we reproduced. We assume that what you submitted to us, linear regression in this case, is the model that was used, but we can't reproduce your score. However, if you submit to us XGBoost, the scores will match, but you will be penalized for using the wrong model in this competition. See the gradient rubric for different penalties or bonuses we use. We'll run your model to reproduce MAE, verify what the model is allowed, respects runtime, and re-rank the score. Those ranks are the ones that will be used to grade this component of the competition. There are other components which is based on team organization, documentation, runtime, and so on. See gradient rubric for that. If we go to the competition in Kaggle, there is a submission link. If you click on that, all the models you've submitted to Kaggle will appear here, and Kaggle will ask you to select the model that you think should be scored on a private leaderboard, or allow Kaggle to select the top public leaderboard submission for scoring it on private leaderboard. We highly recommend that you do that. Here's an example of another competition I was in. It's called Toxic Comments. Was a few years back. I have my private scores and public scores. This competition is closed now, so everything is released. I have an option of picking which one I want to be sent to the private leaderboard. I can't do this anymore. That's why the options are disabled, but it says here, select this submission to be scored for your final leaderboard score. Leave this blank unless you have a strong reason not to. You can contact the teaching team to consult on whether you have a good reason for picking a different model than the ones that generated the top public leaderboard score. That's all I wanted to say. Keep on learning. See you in class.